Hi, welcome. In this video, we will solve problem nearest smaller number on the left. Now let's check out this problem nearest smaller number on the left. Okay. So we are starting learning stack queue data structure. Okay. So on stack, this is the most fundamental problem. Okay. So if you want to learn stack, okay, if you want to solve problems, this will be your first problem to start solving and moving ahead with the stack data structure. Okay. So given an array of integers, find the nearest smaller number for every element such that the smaller element is on the left side, and if there is no as such element, add -1 to the answer array. So let's see how this problem is. So for, you can see this is my input array. So for 34, there is no smaller element on the left side. Okay, so that's why the result is minus. For 25, there is no smaller element on the left side. Okay, 34 is greater than that. So that's why -1 here. For a 10, there is no smaller element on the left side. That's why -1. For 5, again, there is no smaller element on the left side. -1. For 16, yes, there is one smaller element and that is 5. Just next is smaller element. And for 20, yes, 16 is the smaller element. For 18, 20 is not the smaller element, but 16 is, right? So 16 is the smaller element. And for 1, 18, 20, 16, 5, 10, 35, 34, there is no smaller element for 1. And that's why we have -1 as an answer. Similarly here for 6, there is no smaller element on the left side, -1. For 10, 6 is the smaller element. For 5, 10 is the smaller. For 5, yes, there is no smaller element. For 8, 5 is the smaller element. For 28, 12, 8, 6, 5, and for 12, that is 6. Okay, so this is how we are getting smaller element on the left. And now let's see how we can solve this problem. So here I have this an array. Okay, this is an array, and what is the size of it? So 3, 3, 6, 8. Okay, and let me mention the indexes. So 0, 1, 2, 3, 4, 5, 6, 7. So these are my indexes, and how we are going to solve this problem. So basically, what will be your first approach? How you will solve this problem? Okay, so let's talk about the brute force approach one, right? So the approach one that we'll call it as brute force approach. Okay, so in brute force approach, let's see how we can solve this. So you will take first element, right? You will pick one element, okay, and you will traverse on the left side in seeking with, is there any smaller element than the current element or not? So for 34, there is no smaller element. Okay, so let me copy this. You will simply turn -1, and you will take next element 25, and you will move to the, from here you will move to the left elements. Okay, so for 25, there is no smaller element, right? Yeah, this is the same brute force approach that we discussed. 10, there is no smaller element, right? So you will again, from starting from 10, you will simply traverse in this direction, right? So for similarly for 10, there is no smaller element. For 5, there is no smaller element. 16, 5. For 20, right, you will move, start from 16 and you will move in this direction. Okay, you will move in this direction. So for 20, there is 16 as a smaller element. For 18, there is 16 as a smaller element. And for -1, there is no smaller element. Like here it is mentioned -1, it should be 1. Let's see if it is. So yeah, for -1, it's also not smaller. N is equals to 8. So yeah, this will be our brute force approach. And if I write the code of it, so code will be very, very simple. So what basically we need to do here. So I will start from, I will take one loop that will start from 0 to n, right? The length, I will say array dot length. Okay. Now in this loop, okay, what I will do, I will start from j equals to I minus 1. Okay, and I will go till j is greater than equals to 0. Okay, I will run till here, and what I will do, I will simply check if there is any element, any jth element which is lesser than the ith element, okay, what I will do, I will simply put in my answer, I will say suppose answer dot push the element which is smaller, that is jth element, okay, and suppose if I'm not able to find it, so if I simply run this loop, I will come to as my j will be somehow -1, right? So if my j is equals to -1, that means I'm not able to find any element there, right? So what I will do, also I will break it, right? So if I break it, I will simply come out from it. So if this condition exists, simply break it. And if I am coming here, I will simply mention that answer dot push -1, okay, and yeah, this will be our approach. So here you can see this loop will run till array length, so that is size of the element, so this is the end time, and I am running from I-1 to 0, okay, so it will not totally end, but it will be 1 plus 2 plus 3, yeah, sometimes different, right? So eventually the whole time complexity, right? So the for one element it will run only one time, for two element it will run two times, for three element three times, so on, right? So if I move in this direction for 1 2 3 and so on till up to n, so the time complexity will be n into n plus 1 by 2. This is the sum of natural numbers, okay, and these will be your iterations, so you can see that your iterations will be somehow near to this one, and the time complexity will be big O of n square, and we are not taking any extra space. The only space I am taking, that's an answer array to display it, so yes, you can consider this, okay, if you are taking answer array, so the space complexity will be big O of 1, sorry, not big O of 1, big O of n, because n is the size of my answer array, right? So yeah, this will be one approach. Now how we can optimize it? Yeah, your interviewer won't be happy from this your answer, he wants you to optimize it, okay. Now let's find basically how we can get an intuition of optimization here, okay. So okay, so that we have solved it with one approach, okay, that is fine, we were able to do it. Now let's see, is there any approach? The only thing that comes to your mind that you have this current element and you will simply seek for the lower element, smaller element in this direction, okay, that's only approach we can guess. But let's think our numbers a bit differently, let's see our numbers a bit differently, okay. So for 34 there is no element on the left side, right? Okay, so there is nothing. I will simply say it's empty. So let's see what I am going to say. For 34 there is no smaller element on the left side, so any number that is smaller than 34, okay, let's see what I am figuring out till here, that for 34 there is no smaller element, okay, so any number, okay, any number that is less than 34, that is less than 34, can I say will there be a smaller element for it? No, absolutely not, because for 34 I was not able to find the smaller element. So can I say that a number that is less than 34 or equal to 34, there won't be any smaller element for it? Okay, now if the number is greater than 34, okay, then 34 can be the smaller element for them. Yes, 34 can be the smaller the element for them. So I am getting here 25, which is smaller than 34. I am not able to find for smaller element for 34. Can I say I won't be able to find for 25 as well? Right? -1. Now again, same thing. I'm not able to find a smaller element for 25. Can I say any number that is smaller than or equal to 25 here in the next series? There won't be any answer for it. There won't be any smaller element for it. So yes, for 10, there is no smaller element, right? 10 is smaller than 25. There is no smaller element. Okay, but a number that is greater than 25, it is greater than 25, there can be smaller element for it, and 25 can be the smaller element for them, right? Similarly, now let's see 5. Okay, similarly for 10 there is no smaller element. So can I say for a 10 any number that is smaller than 10 or equal to 10, there won't be any smaller element for it? And yes, that is, we have 5 and there is no smaller element for 5. Same for 5. Can I say that number that is smaller than or equals to 5, there won't be any smaller number for it? But 5 can be the smaller element for the number greater than 5. Yes. So here I am getting a number that is greater than 5. So for them, 5 is the smaller element. Okay. Now, so for 16, I'm able to 5 as the smaller element. Okay. So any number which is greater than 16. Okay. If a number that is greater than 16, so 16 will be the smaller number for them. But any number that is less than or equal to 16, but greater than 5 for all these numbers from 16 to 6, for all these numbers, okay, the smaller element for them will be 5. No doubt. Can I directly comment on it? I don't need to traverse this complete direction. I just can directly say that any number that I'm getting from 16 to 6, the smaller number for them will be 5. And any number which is greater than 16, the smaller number will be 16 for it. So the next element I'm getting 20, which is greater than 16. Can I say that 16 is the smaller element for it? Yes, it is. Okay. Now for 20, the smaller element is 16. Same talk with that for 20, any number which is greater than 20 or equal to 20, the 16 will be the smaller number for it. Okay. Any number which is greater than or equals to 20, 16 will be the smaller number for them. But any number that is smaller than 20, okay, that is smaller than 20 but greater than 16, right? So smaller than 20 again, smaller than 20 or equal to 20 but greater than 16. So that will be from your 20 till 16, right? For all these number, for 16, or you can say suppose 17, from 20 to 17, that means how many numbers we have covered? That means we have 17, 18, 20. If these are the numbers, if these are the numbers, okay, or more than that, right? Or more than that, 17, 18, 20, 20. If I'm going more than that, from 20, let's suppose 21, okay, then 20 will be the smaller number for. But for 17, 18, 20, can I directly say that 16 will be the smaller number? Because for 20, 16 is the smaller number. Any number that is greater than from 16 but less than 20, for them the 16 will be the smaller number. You don't need to traverse completely, right? So I am getting 18. So for them it is between 20 to 16. Yes. So smaller number for them will be 16. Now for 18, I am getting 16 as the smaller number, right? Can I say that any number that is greater than 18, okay, I will simply say that 18 will be the smaller number for them, okay, like 20, 21, 22, 23, 18 will be going to be a smaller number for them. Greater than 18 means 19, even into. But any number that is smaller than 18, okay, smaller than 18 or equal to 18, okay, but greater than 16, that means 17, okay, for them the smaller number element will be 16 if it is lie in this bracket. Okay, so here we are getting -1. Okay, so what I will check, I will, instead of checking the whole numbers 18, 20, what I will check, I will check is 16 is the smaller number for them? No, it's not. Then I will check for 16, what will be the smaller number? Okay, that is 5. Is this is the smaller element for them? No. Okay. Now for 5, there is no smaller element. Can I directly say, can I directly say for -1 also there won't be any smaller element? And yes, there won't be any smaller element for -1 as well. So here in this approach, you can see I am predicting just by taking this consideration, like for 34, there is no smaller element. Okay. So any number that is greater than, that is less than 34, there won't be any smaller number for them. Okay. Let's understand this by one more example. So suppose I have this as an array. Okay. And this is my array. Let me mention the indexes 0, 1, 2, 3, 4, 5, 6, 7. And let's see again. So for 6, there is no smaller element on the left side. So -1. Now for 6, I'm not able to find any smaller number element. So any number that is less than or equal to 6, there won't be any smaller number element. The answer will be -1. Any number if I'm getting that is less than or equal to 6, can I directly say that it will be a -1? So for 5, I can directly say that it will be a -1. But any number, okay, that is greater than 6, can I say 6 will be the smaller number element for them? So I am getting 10. So 6 will be the smaller number for them. Okay. Now for 10, I'm getting a smaller number as 6. Okay. So numbers that are lying between greater than 7 to 10, the smaller number for them will be 6. Okay. But if a number is smaller than 6, then there won't, then I will check for 6, what is the smaller number? There is no smaller number. So can I directly say that there won't be any smaller number for them as well? Right. So for 5, I can directly say there won't be any smaller number for them. Right. So here basically, let's see that we have 8, right? So what we were saying, for 5, there is no smaller element. For the 5, there is no smaller number element. So any number that is less than or equal to 5, there won't be any smaller element for him. Any number that is smaller than or equal to 5, there won't be any smaller number element. But a number that is greater than 5, so the 5 itself will be the smaller number for them, right? So for 8, 5 is the smaller number for them. Okay. So same thing, number is 8. What is the smaller number for them? That is 5. Okay. So any number that is greater than 8, can I say any number that is greater than 8? So there will be a smaller number 8 only, but any number that is lying between 6 to 8. Okay. For them, the smaller number will be 5. So I am getting next 20, or for 20, 8 is the smaller number element, right? Let's see for 12. So for 12, for 20, 8 is the smaller number. For 20, 8 is the smaller number element, right? So number that are lying between 9 to 20, okay, for them this 8 will be the only the smaller number. So here 8 will only the smaller number for them as well. Okay, so for 12, 8 is the smaller number. For 12, 8 is the smaller number. So the number lying between 9 to 12, okay, 8 will be the smaller number for them, right? It will be the smaller number for them, but I am getting 6. So what I will do, I will check, okay, what is the smaller number of 12? That is 8. But what is the smaller number for 8 then? Right? And that is 5. That is 5. So can I say for 6, 5 is the smaller number element? Because that is lying between 5, 6, 6 to 8. Right? So that is 5 here. For 12, we have 6. So basically, this is an intuition, right? Don't think like this is how getting complicated. No, absolutely not. It is very simple. But I am just giving you that you are learning this for first time, how you will get to know the concept of stack data structure, how you will get to know that we need to apply stack here, how you are getting an intuition. So the basic intuition is that we don't need to traverse completely. We don't need to traverse completely. We just need to find the smaller number, a smaller number for our element, the most recent smaller number. Okay. and then we need to comment on. We need to find the most recent smaller number, or you can say the nearest smaller number. Okay. So now recent smaller number, recent smaller number, it's giving a sense of LIFO, right? Okay. LIFO means last in, first out. The number that I have added in the last, recent added. Okay. LIFO, that is last in, first out. And whenever you are getting this concept last in, first out, there will be an application of stack data structure. You are going to apply stack data structure. So last in, first out. So basically what I'm saying, the number that I have added most recently, okay, just now, the number that I have added recently, I added recently will be the number that will come out. Okay, will be the number that will come out. Okay, that I will take it. That will be my smaller element. Okay, so what we will do, we'll create a stack data structure for it. So let's understand how we will apply stack data structure. So this is my stack. Basically, it will help me to find the most recent added element, most recent smaller, recent smaller. That's why I am using a stack data structure. Okay, it will help me to find recent smaller. Okay, so this is my stack, works on LIFO principle, and now let's see how we will solve this problem by using LIFO. So I got one element, that is 6. Okay, I will check my stack. Is it empty? So it is empty, that means there is no element. So for when there is no element, I will simply say that I am not able to find the smaller element. Okay, I will simply say I am not able to find the smaller. But that 6 can be become the smaller element for the other elements, right? Greater than 6. Okay, if the number is greater than 6, that can be, then 6 my itself number can become the smaller number for them. So I will mention 6. I will put 6 into my stack. Okay, this is how I will put it. Then I will, for 10, I will check in the stack. Is there any smaller number element than 10? Smaller number from 10? Yes. 6 is smaller than 10. So yes, I will simply add 6 here. Okay. And 10 to it. Right. Why am I adding 10? Because my 10 can be the smaller number for the future elements. Right. For the future elements, my 10 can be the smaller element. I will move ahead. Okay. Then I will check for 5. Is this 10 is the smaller element? 10 is the smaller element for 5? No. So what I will say, I will say why, what you are doing in the stack, right? So out from the stack, because this stack for the recent is smaller. If you are not smaller, just simply get out from the stack. So it will get out from the stack, and I will check then. Is 6 is the smaller element? 6 is no. This is also not a smaller element. I will say get out from the stack, right? I just want recent is smaller. Then this stack is empty. I will say then there is nothing for me. The answer will be -1. Okay, but 5 can be the smaller element for the future elements. So I will mention 5 here. Okay, now 8. I will check, is the topmost element in the stack 5 is smaller than 8? Yes, it is. So yes, you are my element. Okay, you are my smaller element. Okay, but 8 can be the smaller element for my future elements, right? So I will simply move it. For 20, I will check the topmost element. Is 8 is smaller than 20? Yes, it is. So yes, 8 is the required answer for here. It is the smaller element. And I will add 20 because 20 can be the smaller element for my future elements. Okay. And I will check 12. Is 20 is smaller? Again, always see, I am checking the most recent. I will checking the top of it, top of the stack. Okay. So I am checking from the top of it. Remember how stack works? Basically, stack of books. If you can remember, stack of books. So suppose I have placed one book, then on the top of it, I have placed one more book. On the top of it, I have placed one more book. On the top of it, I have placed one more book. So if I want to take out one book, I will take out from the top. Then I will take the second out from the top. Similarly, I will check, is Is 20 smaller than 12? No. So why you are here in this stack, right? There is no use. Okay, just leave it. Is 8 is smaller than 12? Yes, it is. So 8 is my element and 12 can be the smaller element for my future elements. Okay. Now for 6, is 12 is smaller? Is 12 is smaller than 6? No. So why you are here? Simply move out. Now you can see from 12, I'm not checking 20. Just simply checking my stack, that is 8. That is 8. Why? Why? Because I found for 6, there is one mentioned 12. Okay. But 12 is when 12 is not less than 6, for 12 is not less than 6. So I just to check what is the smaller element for 12. Okay. I don't need to check 20. I don't need to check 20 because 12 is not my answer. But what was the answer for 12? That is 8, right? So let's find check out by that. Is 8 is smaller than 6? No, 8 is also not smaller. So I will simply leave out. Leaving out, I'm checking what is the smaller number element for the 8. That was 5. Okay, so I'm directly comparing with now 5. Okay, I left 20. I left all the numbers in between. Okay, I'm checking is 5 is smaller than 6? Yes, it is. So I will mention 5 and I will add 6 because that can be smaller element for the future elements. Now I will move to 12. Okay, is 6 is smaller than 12? Yes, it is. Right, so I will simply mention 6. Yeah, here this will be my answer, minus 1, 6, minus 1, 5, 8, 8, 5, 6, and this will be your stack. This will be your answer, not the stack. So simply I will edit here as this my answer that I am getting minus 1, 6, 6, minus 1, 5, 8, 8, 5, and 6. Right, this will be my answer. Okay, so you can see, right, I am not checking all the elements. I am just checking because for 6 I am checking 12 is the 12 is smaller element. No. Now if 12 is not, so then 20 won't be the option, right? Because 20 is greater than 12. So 20 to hoga hi nahi, right? Now I will just need to check for 12 what was the smaller element, that was 8. So I will directly compare for 8. Okay. Now 8 is not the answer. I will check for 8 what was the smaller element, that was 5. Right, so I will directly compare with 5. This is how I am moving, right? And this is how you can solve this by using stack data structure. Okay, and now let's see how we will write the code of it. So if I can create it here only, so we will run a loop, okay, for I is equals to 0 to array dot length. Okay, we'll run a loop, and before like starting can create one stack. Suppose I have created one stack. Okay. Also I can create one answer array. Okay, so there will be two spaces, one for answer, one for stack. Okay, now I just need to check, okay, that while if my stack dot empty, right, if it is not equals to empty, or instead of this empty I can simply say my stack dot length is not equals to 0, that means it's not empty. Okay, and and the stack element, the topmost element of the stack, right? So I will simply mention as stack top, and top is nothing like stack dot length minus 1. If stack top element is greater than equals to my current element, okay, current element, what should I do? I will pop the element, right? I will remove out from the stack, because if the current element, okay, if my stack element is greater, if my 6 is greater than the element that I'm finding here, right? 6 is greater than that, then there is no need to be present here. I just want smaller elements here. I just want smaller elements here. So if you are greater, if on the stack you are greater, simply remove from the stack, right? So I will simply say stack dot pop. I will remove it. I will remove it. Now, when you are coming from this while loop, okay, okay, if you are coming from this while loop, there will be two chances that either my stack length is empty, so stack dot length is equals to 0, So if it is the case, stack dot length is equals to 0. What I will say, I will simply say simple answer dot push -1, because I am not able to find any element here. Okay. Else, this is not the case. Okay. The stack, you are coming from here because the stack element is smaller than that, smaller than the current element. So what I will do, I will simply say that answer dot push the element, whatever the topmost element is, right? So stack top added to the answer. Yes, and these were the things that I will only do, right? So here the closing of while loop, this is my if, and this is the closing of for loop. But before this, okay, my element can be the smaller element for the next element, right? For the next element. So what I will do, I will always, before after the for loop, I will always push the element. Okay, I will push the element array I, because that can be the smaller element for my future elements. Okay. So if you check the time complexity here, so it will run from 0 to n. Okay. And we have a while loop, right? So don't think this is while loop is also present. Okay. Remember, for loop and while loop both are not simultaneously running. While loop will only run when there is a stop and for loop. Okay. They won't run in a like same manner. Okay. So suppose if this is running for n times, in one of the case that can happen that your stack will also, like this while loop will also run for n times, right? So if it is running for n times, this will also running for n times. So it will be total 2n times, 2n times max to max that I am taking the worst case here. Okay, max to max that I am taking worst case here, and the time complexity here, because ignoring the constant, that is big O of n. Okay, what will be the space complexity? The space complexity, if I am taking about the stack, that the maximum element that can store in the stack, that can be the n elements, nearly about n elements, right? Okay, because suppose all the elements were smaller. Okay, so it can store n elements there, and the space complex n for this answer array, right? So for this also we are putting n, for this also we are mentioning n, so it will be 2n again. This will eventually come as 2n, ignoring the constant, it will become big O. So time complexity will be big O of n, and space complexity will also be big O of n. So in the next video, we will check out how we will implement this problem, how we will implement the logic. Okay, so check out the next video.